Hi everyone, welcome to part 2 of my 5G NR resource grid and resource blocks video. In part 1 we discussed about what exactly is meant by a resource grid and what is the fundamental unit of a resource grid, what is a resource block and how does the bandwidth of a resource block change in accordance with the numerology and subcarrier spacing. Um, um, so if you haven't watched part 1, I would highly recommend watching it so that you get a basic introduction before we go look into common resource blocks and point A. I'll link part 1 in the description. In part 2, we discuss how the base station builds its resource grid. Like where exactly does a resource grid start? What is resource block 0 in the frequency spectrum? So the answer to this is point A. Point A is one of the most elegant concepts in 5G NR. So let us find out what exactly this is and why this matters. Before we go into details, please note that all the information that is provided in this video is publicly available in 3GPP specifications. I have kept all the references, be it books or specifications, in description. Please take a look at it if you want to know more. Now let us take a detailed look at the subject of this video, which is common resource block and point A. Here is the challenge that common resource blocks and point A are designed to solve. So when a 5G phone first turns on and when it starts looking for the base station, it does something called as an initial cell search. It scans the entire spectrum and finds out the SSPBCH block, which is the synchronization signal and PBCH physical broadcast channel, and it finds the frequency location of the SSPBCH block. So from this, the UE learns the cell identity, the system timing, and then the MIB. But so here is the problem: the SSPBCH block is not a fixed location within the entire 5G spectrum. This is the location of the SSPBCH block is not standardized. It could be anywhere within the carrier. So the UE doesn't know where the overall resource block or the resource grid starts. And since 5G supports multiple subcarrier spacing, each numerology has its own grid and they don't actually automatically align with each other. So the network needs to provide a single reference point for all the numerologies so that the UE can identify where exactly the resource grid starts in that particular bandwidth for that particular numerology. This reference point is called as point A. Common resource blocks or CRBs, they provide the universal reference point for the entire carrier. So they span the full channel bandwidth. So they are numbered from CRB 0 and starting up from the bottom edge upwards. The key word here is common. So these common resource blocks are the shared map that any numerology can refer back to. So think of these CRBs like your office building. So no matter what type of vehicle that you are arriving in, say you are arriving by bike, you are arriving by a four-wheeler, you can always find the office building. So similarly, no matter which subcarrier spacing the UE uses, it can always identify the carrier by the common resource block and its number. And at the very bottom of this common resource block numbering, that is at CRB 0, sits the point A. So let me be very precise about point A. Point A is the center frequency of subcarrier 0 of common resource block 0. This is a single precise frequency value. So this is not a range, this is not a block. So think of point A like the origin of your coordinate system. So even if your data only lives at coordinate 10 through 100, you still need 0 defined so that everything has a consistent address. So this is exactly what point A provides. I repeat, point A is the center of subcarrier 0 of CRB 0. So this diagram actually shows the key insight about point A. Look at all these 5 numerologies. So 15 kilohertz, 30 kilohertz till 240 kilohertz. Each grid has its own different sized common resource blocks. So common resource blocks are narrow for 15 kilohertz while they are quite wide for say 240 kilohertz in FR2. But they all share the same um, point A on the left. So point A is the center of subcarrier 0 of CRB 0 for any of the numerologies. This is a constant frequency value across all the numerologies. So the right edge of the CRBs doesn't need to align to each other because each block has a different subcarrier spacing and different width. But the left edge, the starting point, the point of reference for all the CRBs align at point A. So how does the UE find point A? The process of finding point A actually involves two pieces of information working together. The first comes in the PBCH payload itself. So this parameter is called as KSSB. And then the second one comes from SIB1, and then this is called as offset to point A. Offset to point A tells the UE how many resource blocks separate the SSPBCH block position from point A. KSSB specifies the subcarrier level offset between the SSPBCH block and then the nearest CRB boundary. In case if this explanation is not clear, I'll explain this in more detail in the coming slides with a diagram. So by combining this KSSB and then offset to point A, the UE can calculate the precise location of point A. Once point A is known, then the entire common resource block numbering is known to the UE. Then it can map the entire resource grid because CRB 0 starts at point A. Then every subsequent CRB is like exactly 12 into subcarrier spacing above the previous one. Now this diagram actually gives a complete picture of what exactly is point A and what is KSSB and what is offset to point A. So when a user equipment wakes up, say from aeroplane mode, what does it actually do? It does an initial cell search. So in the initial cell search, it firstly detects the SSPBCH block from where it can identify the cell ID and timing. So it decodes the PBCH block to get MIB or master information block. From MIB, it gets KSSB. So I'll explain what KSSB is in detail. Then MIB also gives PDCCH config SIB1. Thus, the UE is able to find and decode SIB1. SIB1 gives offset to point A. What exactly is offset to point A? Offset to point A is the number of resource blocks between CRB 0, that is common resource block 0, and then the resource block that overlaps with the SSPBCH block. So in this case, there are n plus 1 blocks between the resource block, the common resource blocks that overlaps, that is used for calculating the SSPBCH block, the resource block that overlaps with the SSPBCH block, and then CRB 0. Thus offset to point A is clear. Then there is another parameter called as KSSB. The UE decodes KSSB from MIB. KSSB is the number of subcarriers. It's the subcarrier offset between the start of common resource block N that overlaps with the SSPBCH block to the start of SSPBCH block. And then by calculating back offset to point A plus KSSB in subcarriers, you will get the point A. So thus the UE knows the exact frequency location of SSPBCH block after the initial cell search procedure, and then by subtracting this frequency location, the UE will be able to find out point A, which is the center of subcarrier 0 of CRB 0. Now, this is the case with TDD. So in FDD, the UE is provided with an absolute frequency point A, absolute an ARFCN number which helps in identifying point A. Now let us look at offset to point A in detail. So this parameter is provided in SIB1. It tells the UE how far the SSPBCH block is from point A. So this is measured in resource blocks. So KSSB and offset to point A are measured in different units. Then let us look at KSSB. So while offset to point A gives you the resource block distance, it gets you to only like 12 subcarriers within the SSPBCH block. So KSSB provides that final precise resource subcarrier level frequency offset. So this is the subcarrier offset from the edge of the common resource block pointed to by the offset to point A down to the subcarrier 0 of the SSPBCH block. So for FR1, for frequency range 1, KSSB goes from 0 to 23, and so that's like 24 values. So this covers the maximum possible subcarrier offset, whether the SSPBCH block uses 15 kilohertz or 30 kilohertz subcarrier spacing. In combination with offset to point A times 12 resource block subcarriers plus KSSB, you get the exact number of subcarriers from point A to the SSPBCH block. So multiply by the reference subcarrier spacing and then you have the exact frequency offset to point A. So now the UE knows point A to subcarrier precision. So the complete set of common resource blocks may not be used for transmission. So let us consider a subcarrier bandwidth of 20 megahertz, which accommodates around 106 common resource blocks when using 15 kilohertz subcarrier spacing. So these 106 common resource blocks are equivalent to half the number, which is like 53 common resource block when using a 30 kilohertz subcarrier spacing. However, 3GPP specifies that the 20 megahertz channel bandwidth can accommodate up to 51 resource blocks when using the 30 kilohertz subcarrier spacing. This means that common resource blocks 0 and 52 remain unused. So this diagram here actually shows the relationship between these three key references on the frequency axis. So the red marker here, this is point A, and this is the start of the useful resource block on the resource grid. So there is an offset to carrier specified a number of resource block between point A and then the useful resource block start. This green block shows the carrier bandwidth. So this is the number of usable resource blocks from the carrier start to the carrier end. So this dashed line indicates the SSPBCH block, which is located somewhere inside the usable carrier bandwidth. So once the UE has this all these values from SIB1, it has a complete precise frequency map of the carrier. So every subcarrier, every resource block has an unambiguous position related to point A. This frequency info downlink SIB is the SIB1 parameter that delivers all this information to the UE. It contains offset to point A and then it contains a subcarrier spacing, specific carrier list which specifies the offset to carrier and the carrier bandwidth. So with this single SIB1 message, the UE can reconstruct the entire resource grid with a specific location for each subcarrier. Okay, now let us recap part 2. So point A is the universal frequency anchor. Point A is the center of subcarrier 0 of common resource block 0. The UE finds point A by combining two parameters. One is KSSB, which is obtained from PBCH, and then there is offset to point A, which is calculated from SIB1. So the UE combines offset to point A and KSSB to find the exact location of point A. The ASN1 parameter called as frequency info downlink in SIV1 provides the usable carrier bandwidth and then the offset to carrier, which is the start of the usable carriers that can be used, and thus the UE construct the entire frequency map of the carrier. So that is it about part 2, and in part 3 we will build on this foundation. So now that we know where the frequency grid is, what happens when a UE cannot receive a full carrier bandwidth. So that's the problem that bandwidth parts solve. We will look at this in detail in part 3. See you in part 3, and thank you for watching. Bye bye.